Folks, I've been working with my dog lately. It's a great dog at the house, but it was a pandemic dog. It's one of these dogs you got during the pandemic. So it's not great with new people and new situations. Very loving, very sweet dog around the house, but just incredibly nervous outside of the house. Doesn't bark at anybody, but just wants to go home. And so we're trying to get it to associate new situations with nice things, with treats, with like hearing a nice sound and being like, hey, come over here. And if you hear a bang or see a car drive towards you, come over here. You can get a nice treat. You can come and nibble on this. And I just wish someone would do that for me. I wish someone would just follow me around and be like, hey, did you have a rough day? Here, have a little piece of candy. See, it'll cheer you up. And I'll start to associate difficult situations with good things happening. Folks, it's time for the OpenTelemetry webinar. Thank you so much for joining us. I've started telling a little anecdote at the beginning of the show instead of saying, I think we're streaming. I think it's live because it gives me time to check that we are live. And we are live. And let me hide this for a sec. I promise that we are going to talk about the OpenTelemetry Trace API, but we have Srikanth as our guest. Oh, nope, you're on this side. Srikanth, our guest today. Introduce yourself. Tell them what you do for the SigNoz team.
Hey everyone, I'm Srikanth. I work at SigNoz. I mostly work on metrics and the alerting parts of the SigNoz system. Also spend a quite amount of time working in OpenTelemetry. I used to be maintainer for OpenTelemetry Python SDK and also currently work with the OPAMP. Yeah, that's briefly
Awesome.
about me.
And you're here today because we had an episode about the API in general and like the division between the API and the SDK. But it became obvious that we wanted to talk about we wanted to talk a little bit more in depth around multiple aspects of this API. And so I wanted to talk today a little bit about some of the questions that I had about tracing. And of course, as you're joining this this call, please do feel free to pop into the comment section and add your own questions. I know we have a great audience lately that's been giving us great questions during the show, so really appreciate that. So we'll ask some of those here, but these are the ones that I wrote. We have a little walkthrough through it. And how do you want to go through this? Do you want to just start with your slides first, or however you'd like to do it?
Let's start. Let's start with the slides first.
Cool. And so sorry you can't advance. I will advance the slides. So you just say next slide. I will move on to the next one.
Yeah. Yeah. So I will give a brief overview about this, like what set the agenda. So that in the last session that we had that I had we looked into what are the different aspects of the open, like what are the major parts in OpenTelemetry, what is API, what is SDK, what does collector do, who cares about what. Today we want to talk about the Trace API in detail. So this is particularly relevant for the folks who like there's a much of there's some amount of telemetry data that you get of the out of the auto instrumentation, but to be really make use of the OpenTelemetry to its full potentials, you need to start instrumenting your own code. So at some point, auto instrumentation is great to get started with it, but it's not the end. So you need to, at some point, to make a good use of it, you need to you need to start manual instrumentation, and that's where this having some idea about the Trace API gets into picture.
Now, one question that I had, that was my first question, was like, hey, do you think, kind of everybody is going to end up doing some amount of manual instrumentation? And my understanding is always that it probably makes sense to do some kind of hybrid, right? Where it's not that you're saying, oh, we use automatic instrumentation and then you pull it out and start all your traces manually. It seems to usually make more sense to say, hey, you have automatic instrumentation running. It's maybe what is kicking off most of your traces or what have you. But yeah, it's running, and then you're adding to it with manual calls. Is that generally what you would expect to see?
Yeah, so it's so correct. And so what you do as a what you generally do with the manual instrumentation is you're probably not going to start the trace by yourself, because the auto instrumentation is at the forefront. Like it already starts the trace journeys at somewhere even within the framework. So what you would generally do is, so there are certain parts of your code base and in your application which are not covered by the auto instrumentation. So what you generally do is add a span. So you start a new span. Let's say you have some auto instrumentation spans that's at the start of the framework request, but there's nothing beyond that. But you have a certain functionality within your application which is not traced, but you would like to, because that's where the most contextual information is available. So there you generally start the span. Since there is already a trace started upstream, what you get is you whatever the span that you're generating within your application, it's tied up to the existing span. So there's no new. You generally don't create a new trace altogether from on your own, unless there's a very specific requirement.
Yeah, and this makes some sense, right? Is like there are always going to be chunks of your code base, right, that aren't hit by auto instrumentation at all, right? That's like, hey, I wrote this handling code, I brought in some math library but I'm handling web requests, right? But generally, right, if you are some kind of web server, right, kicking off a request is pretty straightforward, where there should be a million little hints to the people who created this automatic instrumentation library that, like, yeah, I think a request is starting now. I think we're handling something that we want to call a new trace. So yeah, you're very often adding spans, not saying, hey, this trace is just getting missed. Obviously, like in my time, I have seen examples where it's like, oh, this one type is not showing up. And I'm sorry, we can hop back to the presentation. I didn't mean to get us off track with my questions already, but
yeah, we can alternate between the questions and the slides. That's
nice.
All right. Next slide, please.
Okay.
Yeah. So I want to give a brief idea about what are the. So when you get started, when you want to start, manual instrumentation, like they are having some understanding of the concepts helps you, work with that manual instrumentation well. And when it comes to the a tracing API of the OpenTelemetry, so these are the main parts. So there's a tracer provider, there's a context, there's a tracer, and then there's a span. So we will we'll first I'll give a brief idea about what tracer provider does. So the provider gives you the access to the tracer, and tracer gives you the access to the span. So this is like, look at it as a hierarchy. So you have a provider that gives you the tracers, and then a tracer object which enables you to create the spans. Next slide. Let's talk about the tracer provider. So the tracer provider, like I mentioned earlier, tracer provider is the provider object which helps you to get a tracers. You could ask why is there a need for even a provider here, right? Why could you not just start the span? Why even have this hierarchy structure, and then why have that obtain the tracer object first and then try to create a later. So this is, look at this as a even a further granular level of telemetry information. So let's say you have a n number of modules within your system, and you don't want to and you would want to scope each tracer. So let's say each tracer that you create has a name associated with it and the version associated with it, and there's a schema URL set of attributes, right? So this tracer object, you could have a one global tracer object, or you could have a scope tracer object. So what that means is that, let's say you have a certain piece of code in one of the modules that is following the old semantic convention. So, and there's a set of code that is following new semantic conventions. Or you want to have a, let's say you want to, there's a HTTP call that's being made all over in the application, but how you want to track them is you want to have a scope HTTP request. So let's say a HTTP request within a scope of this a particular module 1, you want to separate it from the HTTP request in module 2. So you would create a 2 different tracer objects. So this tracer get tracer helps you to have a multiple tracer objects which have their own name, their own schema URL. So the schema URL here represents a semantic convention. So let's say if you provide the schema URL as 1.14.0, so any data that you send to the backend will have this information associated with it, so that they know that whatever the data within the scope tracer is coming with a semantic convention of 1.14.0. So that's where this really helps. But in general, in practice, unless you have these requirements, you would generally just use the one global tracer object.
Yeah, so this would be like, maybe in some ways, apparently we have a single service here, but we feel like they're really two totally separate services, say an internal and an external version of some account detail service, right? And it's like, well, we really don't want those traces mixed together. They don't make sense together. Right. And this gets us into the very basic question about like, how much work should you be doing to make sure that your code displays right, that your observability displays right within your code base. And my standard answer is, if it makes sense for your organization and for your data as it travels through your system, then that's something that you should worry about while you're doing custom instrumentation or while you're setting up instrumentation. Like, hey, these are two separate units. These are two separate applications. They handle different types of requests. Then, yeah, you should be encoding that. If it's like, oh, this doesn't make sense and I want to add explanatory details, like maybe there should be a better way to do that than editing your code base. But it totally makes sense to set up your observability at first. This is a perfect example of like, yeah, have like scoped tracers to like, hey, this is what we consider an actual single service here, even though maybe it's part of a like it's getting tracers along with something else.
Next.
Oh, next slide. Got it.
Yeah, so this is how you like in general, in practice you may not need this many scope tracers, but it is possible that you can have a different traces for different purposes. Let's say you want to, within a certain package, you want to like any spans that are emitted within that package, you want to attribute them to a scope. So that's how you do it, com.mycompany.package. And let's say you want even further granularity, you don't want each package, you want each file, you could do com.mycompany.module. So this is the level of granularity that you get. It's up to you whether from a business point of view or from your code point of view, do you want to use if it makes sense to have this scope separation between the tracer and then the spans associated with it, you should certainly use it. But if that doesn't make sense, you can just have one global tracer that's used everywhere within your application.
Totally.
Next. Yeah, next I want to talk about the context. This is really important for you to know, because so how do we so in the entire tracing is based on the fact that spans are connected together by parent-child relationship, right? So how does that happen? So so there are different languages have different ways of managing it, but it's all so how does this parent-child relationship is preserved? It happens based on the context. So this is called context propagation. So there are two types of context propagations. One is in-process context propagation. One is out-of-process context propagation. So we will look into the in-process context propagation, which is where we need to manage it. The out-of-process context propagation is automatically taken care by the client libraries. So let's talk about the in-process context propagation. So let's say you start a span in function foo, and you starting another span in function bar, and you want to have a parent-child relationship, like foo is a parent and bar is a child relationship. So how do you tell when you're creating a spans? how do you ensure that this parent-child relationship is preserved? How do you know that this will be the case? So the way it would be should be done is via the context propagation. In languages like Go, you have the explicit context propagation that you have to take care of. In languages like Python, JS, Java, so there is a implicit context propagation that happens via thread locals, different mechanisms.
Hmm.
um, in those languages you do not need to do anything. So in languages wherever there is a implicit context propagation via thread locals like Python, Java, you don't need to interact with the context yourself directly. But in languages like Go, you need to interact with the language. Anytime you pass a context to the bar, you need to make sure that the context that you send to the bar function is like it has the parent foo span context associated with it. So there are two functions here. One is like mainly that you need to be aware of: span from context, context with span. So these are like creating. So the span from context, what it says is that what it does is that it gives, so given a context object, like if you know the context object from Go, given a context objects, it gives you the span within it. So either if that span does not exist, it will be nil. But if a span exists inside that context, it gives you the span back. And you can interact with span object later. Like there are a number of things that you could do on span object. So the object that you get back from the span from context, you will use it to add attributes, add events, etc. And then there is a context with span. So this is, you create a new context object with a span, which is, so this is used where you want to do the in process context propagation. So let's say you have two functions, or let's say you have three functions. There's a function 1, 2, 3. You want to start a span in 1 and 3, but you don't want to do it in 3. Somehow you need to propagate the parent from the function 1 to function 3. So that is done via a context. So you create a new context object with the span, and you pass this context all the way down to the function 3. And this function 3, you extract the span context. So you extract the span from the context. Either you add attributes or to it, or you create a new span with the context that has come to you from the upstream, like the parent function. um, Next slide, Nika.
If you get back just a span here in the span from context, can you add a child to that span object?
Yes. So you when you so let's say you just get a you when you do not need to add anything on your own. If you just start a new span with the received context object, it automatically does that for you. So you don't need to do that again. So let's just say if your goal is to just add a child, just start a new span with the given context. If you want to add certain attributes or perform certain operations on the existing span object, you will use span from context. Otherwise, you just do the start span with the given context object.
Got it.
Yeah.
So yeah, so the reason you'd be loading the span would be to to ask some questions about like, hey, what span am I currently in? Let me find that value.
Yes. So whatever is part of the context object. So let's say you have there can only be one span as a part of the context. So when you send it down to some function somewhere all the way down, and if you start a new span with the context, the parent-child relationship is automatically formed. If you don't use that context, that's where, so if you come across these broken traces, this is where you need to start looking into. So you need to use the context that has been given to you. Otherwise, what happens is, if you do not use the same context that had the parent, it will create a new trace, and then ideally what should be single trace is now a broken trace in your application. So that's where you need to take care of this detail. So you get a context with the span and pass it down to the functions where you want to have a parent-child relationship, and use the given context object so that the trace is continued without any broken spans. Yeah, this is another example where, okay, you don't want to create a new span, but you rather want to pass it down and add certain more attributes or add certain more metadata and then end the span in that function, right? So the context you received here would have the parent context, parent span. What you do is trace that span from context. So what this is doing is it is extracting the span object out of the context that has been given to this function, and then span.set attributes, and you're setting the span at setting the attributes. You can end the span here, or you can continue pass down the context object to the another set of functions. Next. Yeah, so that was about the context, like having so it if remember this, that anytime if you have certain broken traces, or if you need to connect together a spans which are not connected, the go-to place for you to is to look at the context and make sure that the context is propagated properly. You don't need to worry about it in many languages, but in languages that don't have implicit context propagation, you should take care of that detail. Next up, we have tracer. So we have seen that there's a provider that gives you access to the tracer, and the tracer is the object which is responsible for creating spans. So you cannot create, like you cannot instantiate a span directly, so that's not possible. So if you there's no way for you to instantiate a span directly in OpenTelemetry. You cannot do that. That has to happen via tracer object. So the tracer object is one which gives you gives you access to how to start a span. So any span that you create in your application has to happen from the tracer object. There are two primary operations that are on the tracer object. One is a convenience method, start as current span, and then there is a start span. So the start as a current span starts the it starts the span and sets the span in the context. If you remember from the last slide, we mentioned that there is something called context with span, right? There you as a user are setting the span inside the context. Here, this convenience function, what it does is it does the work for you. So you do not need to set the span inside the context again. So the start as a current span takes the context, creates that span and sets it inside the context and gives you back the new context. So when you pass the context downstream, it already has the parent associated with it. So that's a convenience wrapper, I would say. But the underlying what it is basically doing is simply start the span and attach the span into the context. So the start span is the one which is where you create the span. So this is on the tracer object, you have something called start span. This start span creates a span and gives an instance to you. Next. Yeah, I in the slides I used multiple languages just to give an audience a brief idea, and have put together some examples. So if you look at the example here, on the first span you have tracer.start as current span. So there's a parent span, and inside that there's a tracer.start as current span's child. So here, by using the start as current span, you do not need to manually you don't need to work with the context manually. Like you don't need to worry about, oh, will there be a parent-child relationship preserved or not. So when you use the start as a current span, the convenience wrapper does the work for you, creates the span, sets it into the context. So anytime the child starts, there's a parent-child relationship preserved. Yeah, next.
Matters because something I was just seeing in Hazel Weekly's talk like 4 weeks ago, name checking it, and I'll share a link down to the video once it's shared. But I didn't realize that you could not create these parent-child relationships or connect spans after the fact. Like you can't do it with like a collector setting, an OpenTelemetry collector setting. So if you're seeing like orphan spans or broken traces, like you need to go fix it within your code instrumentation. It's not currently practicable to try and fix it afterwards.
Right, you cannot do that at the collector level, because I mean it makes sense, because how do you know that? How do you, like, how collector does not know how to have this parent-child relationship, right? How does it know that, hey, this should be there and this should be there? So there's no way to do that. Any broken relationship, any broken data, it has to be fixed in the application where you have instrumented for you. This is another example where we are not using the start as a current span, where we are just using the start span. If you are going to use the start span, it is your responsibility to make sure that the context is managed properly, right? So let's say you have you get the parent and put it set it in the set span in the context, and you get the context back, and you have to pass the context object to the child span. If you remember that we did not have this line of context equals to context set span in context in the previous code. That is because that convenience wrapper does the work for you. But if there are certain cases where you don't want to start span as a current span, this is how you would have to do that. It could be because when you do the start as a current span, the timer, the start time, everything is automatically that at the point in time. But let us say if you do start span, you have the option to, so this you have the ability to pass the start timestamp, so which you which
Oh,
so when you do start span, there are a number of arguments that the start span accepts. One of them is start time. So when did this you are not starting, since you are not starting this as a current timestamp, it gives you the ability to say what is the timestamp when this span has started. So that's an advantage. There can be certain use cases where you don't want to immediately start a span, but start a span with certain some time later, or some custom start time which is not the current timestamp. So in those use cases where you do this, we make sure to have context in idea, otherwise you would get a broken process.
I see. Yeah, that's I didn't actually realize that that was possible. Like, and I've seen that where like it's an asynchronous process. There's network between you and the database, but we don't really care about that. And so it's like, oh, I wish I could start it when the database actually starts to handle it, you know. So it's like
Yeah,
not the current time.
I have seen certain users had certain use cases where, with some use cases where they had to pass the, and then they use this pretty extensively, because they get the data from somewhere. Like they don't immediately have this tracing information, but they want to have the traces. So what they do is they get the start time somewhere from the database, or some other means. So they get this, when should I start this operation. So they get that start time from somewhere and use that information to start spans. And still at the end, when you go to your tracing backend where you are looking at the data, you do not know whether it actually was how is it started, how whether it was customized or not. So
Yeah,
this is very useful.
like you get a DB return, a database return that had like, hey, this was the time I received this request, and here's the response.
Yeah,
And I want to add that span, but on the handler for the return, right? So it's like, no, don't
yeah,
start it now because it's done now, right? Like don't always make it the span length like a millisecond, right? Like actually let's show what the actual return time was. So yeah,
yeah.
that's pretty cool. I didn't realize that was an option.
Next slide.
Nice.
Yeah. So now we have seen the tracer object. So there's like, I'm just repeating myself again. There's a provider that gives you access to the tracer, and then there's a tracer object which helps you to start spans. And this is the you like this like the entire work that you do manual instrumentation will be revolved around the span. So anything that you do will be actually it will be on the span object. And then there are a number of operations that you can perform on span object. So there I have listed them. We will go through one of them and how they are really useful. So there's a get context, there's a ease recording, set attributes. We'll go over them one after other. Because next slide please. Right. So now you have the get context. So what does it give you is, so a span has a context associated with it. What does that span context contain is, it contains a trace ID. it contains a span ID, it contains a trace state and flags, it contains a is remote. So what does, so every span that you have in every span that you create has this information. So is this span a remote span or is this a not remote span? When a span is a remote span, means the span you just have it. So let's say you have a two services and you have a service B which is not creating a trace on its own, but it is just propagating the context, like propagating the trace, like it is not, it is continuing the trace that has originated in service A. So in service B, how do you know that? How do we know that it should not start a new span, but it should just continue span? What happens is, under the hood, service B creates a dummy span that has a is remote set to true. What that indicates is, okay, hey, there is somebody has already started a trace journey, so I will create a dummy span with the is remote set to true, and I also it also has this upstream parent trace ID and span ID, and it sets that span in the context and continue and starts the span so that the trace journey continues. This get context helps you get the trace ID, span ID, is remote information. If for some reason, let's say you have a certain business use cases where you want to take these trace ID, span IDs, and let's say you started a span, like how do you get the span ID? Let's say you have a certain requirement that you want to give this span ID to some external system, or give, attach this span ID to one of your other, business intelligence reports that you generate, or any other use cases. So where do you get the span ID, or where do you get the span, trace ID that is associated with the span that you generated? So that is it is done via the get context. So you call a get context on the span object, it gives you the span context, and this span context has this trace ID, span ID on the trace state metadata. I'll show you the example next. Nika, can you go to the next slide? Yeah, so here if you look at it, so what the first line is doing is there's a span that get span context that gives you the span context object, and we have a span ID. I can give you one very common use case that people follow is, let's say you want to you have a you are doing your traces, but you are also want to have your traces and logs associated, right? So you want to include this trace contextual information such as trace ID, span ID as a part of your logs. So how do you get the access to this span ID, trace ID, so that you can include them in your logs? You use the get context. So you use this get span context, which gives you the access to the span ID and trace ID, format them, include them in your logs, so that whenever these logs reach the logs backend destination, there's a good way to correlate between the traces that have been generated and the logs that you send to the logs, whatever the backend that you use. That's one very useful.
I really hadn't realized that you could like set your like start time on a span, but the reason I always knew to like get your current span was to connect and get out your trace ID and span ID. So like, hey, when I'm logging this, I'll be able to connect it to this trace really easily.
Right. Yeah. Next slide. Yes. So now we have another. This is very. It's very unknown. I would say, like not commonly discussed or commonly known. So there's something called is recording. So it tells you whether the span is recording the data or not. What that means is, if is recording is set to false, any operation that you perform on the span object will be ignored. Let us say you do set attributes, you do add event on the span. It is only captured as long as it is recording. How do you know whether what decides whether it is a recording or not? There is something called sampler in the SDK level, where it decides whether it should be recording or not. And it is important that so you can have a certain use cases where you are recording but you are not sampling. What that means is that, let's say you don't want to this a span to go to the destination, but you are still recording it and processing it, so that you have certain SLOs that you report to, and you have certain aggregate data that you report to, but you don't want the whole span to go into the destination system. So in those cases, this is recording becomes very handy. Yeah, next slide. Your voice is you're on mute, Nika.
Sorry. Could this also be for something where maybe you're using the baggage for some other purpose within your engineering, like you're using it for testing or something, and so you would always you'd be passing this trace around, but you're not actually going to record it?
You so it's not really related to baggage. You
Okay.
just want to, with the baggage you just passing around the metadata, but this is recording is it's related to sampling, where you don't want to sample but still want to record. So
Okay. So if you're using baggage for something interesting, like the trace test guys or something, they could just be passing around the context without passing around a trace. Okay,
right,
got it.
right.
Got it. Okay.
Next slide. Yeah. Now next we have a set attributes. This will be the most common operation that you will do on span when you are doing manual instrumentation, because anytime you create a span, the real value comes out of it when you attach some rich contextual information with it. So just starting a span does not alone give you the any meaningful information. It's only useful when you have a context, like some contextual information, and when local whatever the contextual information that has been associated with the when it is started. So the set attributes is the function operation, you would call it, that the span object that helps you to attach. So let's say you could be attaching a customer ID, or you could be doing any contextual information that will help you to debug issues later. And this is where it's really, like there can be certain requests which are specific to certain customers, and not having that customer ID will not be able to help you. So this, when you have this when you start this span, make sure that you add necessary information that will help you to debug issues later. Otherwise, just creating a span and not having the essential attribute set, meaning that it's not really useful. It's only as useful as the data that you attributes that you attach to it. Next slide. And then we have add events. So during your whenever you're tracing, during your span journey, so there is, like, obviously you can have attributes associated with it, but whatever is during this function call, there could be many events that are happening. So you could be, like, let's say you could send an event, like you could send a request to the external system, and whether it is succeeded or not. Like, let's say if it failed, you would want to add, okay, so external call failed event to this span, so that when you look back on your tracing backend, it has this information. Okay, so these are the things that it tried, and there was a failure event, and there was so you could ask, why can't the same be done with the attribute? The attribute only gives you the one specific value. Like you could only add whether it failed or not in the attributes, but having the event tells you a much more information. You could as a event, you could, okay, so this failed event, and when did the event fail, and what are the event failure attributes. So the event is a much more useful when you just don't want to add a simple simple key value, but you have an operation, you know when the event specifically happened, and what are all the event specific attributes. So that's where this becomes important. So let's say you could add that fail, okay, so external event fail, and this is the timestamp at which it failed, and these are the attributes which cause the event to fail. So that's where the add event is really helpful.
Yeah, this is always my understanding, is like an event is just a richer object, right? Like it's not just a single key value pair that you're adding.
Yeah,
So don't add, like, I would say, like, if you have a whole event readout, like e.g. like from a failure lookup failure or something, right? Like don't add a whole bunch of attributes. Don't add 9 attributes
right,
to that span. Like just add an event.
right. Next slide. Next we have add links. I will give a, so add links is useful when you want to link a different traces together, or when you want to when you want to add a traces, different traces together. So let's say you have a certain regular request flow, and then somewhere in the middle of this request flow, there is a branch out logic where a request goes to, you send a request to some queue, right? So within your request flow, regular HTTP request flow, it is time bounded. It is synchronous. Like you get a request, you get the response back. But when you send an event to the queue, you don't know when it will end. So in those use cases, how do you want to connect that whatever the queue has received, like has how whatever the message that processed by the queue, how do you make sure that which request has triggered this queuing object, this message processing. So this is where add link helps. So what you can do is, when you start a new trace, so in the queue system where the new message is processed, you cannot continue the trace journey because it is not a regular request response flow, it is an asynchronous flow. So when you start a new trace and new span, when you're in your message processing system, you start a new trace and you link this trace to the existing trace, because you get the context, link this trace in your queuing system with the regular request response flow, so that in your tracing backend you can go back and check, okay, so this is when you're trying to troubleshoot your messaging systems, you get back to see, okay, so this message, what was the trigger, what was the request flow that triggered this message. This is where the add link becomes useful. It's not very common, but very helpful in messaging systems. Next slide. Next we have set status. So any span that you any operation that you do, right? It has states associated with it. Either the operation was successful or an operation was a failure, right? So this, how do you any span is just representing a unit of operation, right? How do you indicate that whether this operation was, so let's say you make a call to the database, and then that whatever the call that you made, it failed for some reason. How do you indicate that this operation failed? uh, Span has this set status operation, set status method, which lets you to set the status of this operation. By default, that is unset. But let's say you perform a DB a query and it failed for some reason, and we use this set status to say that, okay, hey, this was the operation that I tried to do. And here in this example, we are looking at an external event. So we are making some request call, and if the request fails, and we are setting the span status as an error, so that when it reaches your tracing backend, you know that it is failed. And this is highlighted that in your tracing backend. Okay, it makes it easy to have a quick look at what are those operations that fail. Next.
Yeah, and if it's failing with a third-party API or something, right? Like that's failing to look up a user, that's
Yeah,
not going to show up, but automatically in tracing or automatically in error
right.
tracking as a failure.
Sorry. Yeah, you we need to take care of that detail again in manual instrumentation. Anytime you suspect there can be a possibility of an operation failure, make sure that you set the status, so that you don't miss whether this operation was successful or failure when it reaches your backend. And next we have update name. I haven't seen anybody use this in practice, but once you start the span name, you have the ability to change the name afterwards also. When you create the span, you generally give the span name. But for some reason, you know that you don't want to use the original span name. This update name gives the ability to change the span name. I haven't seen this in practice. Many people use it, but it is possible. Let's say you start with you don't have the enough information to give a proper span name, but you will get it afterwards sometime later. then it perfectly fine to start with some name which does not make sense or which is not very useful, but update it later on.
Yeah, I all I can think is like you're really bought into OpenTelemetry and you have like a constant annoyance around some spam that's like not being labeled correctly.
Yeah, and then so we discussed that there's a start span which accepts the timestamp. Similarly, there is an end method which also accepts the timestamp. So if you do not provide any timestamp when you perform span.end, it takes the current timestamp as the end timestamp, but it gives you the flexibility to give the custom timestamp. So you can start a span at your own time that you have at your hand. You can end at your own custom time. So it's not necessarily that. By having this flexibility, your spans do not need to be like a current as they are happening. So you can start a span with your custom timestamp and end a span with your own timestamp. You are not bounded by the fact that it will only take the end time as a current timestamp as the end timestamp. This gives you the this helps you in a use cases where a start time, end time, certain operations which are there, which you get from somewhere, maybe DB or somewhere, maybe some written to file or somewhere where you do not have them, and but you want to but you want to have a trace created out of that raw data, so that you can visualize it in your tracing system. So the end also has this optional parameter timestamp, which if you don't provide it, it will use the timestamp. But if you provide it, the span end timestamp will be the timestamp that you have given as an argument.
Very
Next slide.
cool, very cool.
And next we have record exception. This is a special. The record exception is an add event. Basically it's a convenience method again. So when you do record exception, it basically adds an event with certain attributes. So a stack trace, exception type, exception message. So there are these certain attributes which it neatly formats for you, but it is just a simple convenience wrapper around the add event. Yeah, so that's all. So we have seen the provider, we have seen the tracer object, and we have discussed about the span, which is like where you work with mostly, and we have also briefly discussed the context which is very important, so that you don't get the broken traces in your system.
Oh, this is so cool because I was writing this week about doing some of this stuff in Python, about adding some manual calls to add details to your traces. But there's a couple that were like I'd seen them but hadn't really thought about how they would be used, like is recording. And yeah, that's pretty nice to see. So this fills our time, so I think we got to come back for another week to ask a couple more of my questions around like tracing strategy. But this was so great. I really want to thank you for taking the time. Let's give a few minutes to see if we have some questions coming in. Just keeping an eye here on the event. Let me see if we're getting questions here in the chat. One sec. And yeah, I'll take a look in YouTube as well. Thank you so much, guys. You usually do ask some great questions. Looks like chat's quiet today, so we're free. You don't have to stay any later today. So that's the good news. Well, folks, this will go up as a blog post on the SigNoz blog as well. You can see us almost every week with their OpenTelemetry webinars. We'll be doing a call soon on using OpenTelemetry to monitor language learning models, which we're super excited about. This was great. Of course, we got to have you back again very soon, and I'm remembering which direction you're in, so it's this way. Thank you so much for joining us. Folks, if you have questions, either go ahead and drop them under the video as comments, or join our community Slack and ask them there. Thank you so much, everybody.
Thank you.
All right. That